Hello and welcome to Empowered Learning. This video will be about exponential notation and how to use it, as well as being able to evaluate expressions that have exponentials in it. So in general, whenever we say something is an exponential notation, what we're really trying to do is find a compact way of saying some number is multiplied times itself a certain number of times. So in this example here, if we have 2 and we want to multiply it times itself 5 times, then a more concise way of writing it is as 2 raised to the 5th power, okay? Where 2 is called the base in this example, and 5 is called the exponential. Sometimes it's also called the power as well. So to do another example, let's say we wanted 4 to be multiplied times itself 3 times. Then we would just write that as 4 raised to the 3rd power. And that's an alternative way of saying that. So in words, let's say if we had 5 raised to the 2nd power. We say it as 3. If we have 3 raised to the 2nd power, then another way we could say that is 3 squared. If we have 3 raised to the 3rd power, then another way that we can say that is 3 cubed. And then anything beyond a power of 3, we just say whatever the base is raised to whatever the power is. So 3 raised to the 4th power would be here. If we had, let's say 10, we'll say this as 10 raised to the 7th power, okay? Or if we had 2 and the exponent was 13, we would say 2 raised to the 13th power. All right, so now let's look at some examples. So what we want to do is evaluate these. And to evaluate them, of course, we just need to figure out what this actually means and then figure out the resulting number. So 2 raised to the 7th is just 2 being multiplied times itself 7 times, okay? And so here, what I'm going to do, I'll group these together. I know 2 times 2 times 2 is going to be 8, because 2 times 2 is 4, 4 times 2 is 8. And I have another group of that as well. So we can rewrite this as 8 times 8 times 2. And of course, 8 times 8 is 64. And 64 times 2 is 128. So 5 raised to the 4 is just 5 times 5 times 5 times 5. And we know that 5 times 5 is 25. And if we multiply 25 times itself twice, we get 625. In the next example, 5 raised to the 1, anything raised to the power of 1 is just itself, okay? And another thing I want to add here is any number raised to the 0 power is the same as 1. And the reason for that is that anything raised to the 0 power is another way of saying that same thing divided by itself. And the reason that that's true is because here we could look at this as a raised to the power of 1 over a raised to the power of 1. And we have exponential rules that say anytime that you have 2 exponential numbers that have the same base but different exponents and they're written in quotient form, you can subtract the exponents. So here, if we wrote this in that form, it would literally look like that. And of course, 1 minus 1 is 0. So that's why this particular exponential rule is true. All right, so now noting that, we see that in this example that 1,000 raised to the 0 power, we wouldn't say it's 0 because we know anything raised to the 0 power is equal to 1. In our next example, we know that 3/5 raised to the 2nd power is just the same as saying 3/5 times 3/5. So we'll multiply that times itself twice. And of course, 3 times 3 is 9, and 5 times 5 is 25, okay? Now, alternatively, we could have also did this way. And we have an exponential rule that says when we have this situation, that we can take both the numerator and the denominator and raise it to the same exponent. So in doing it that way, we see that 3 squared is 9 and 5 squared is 25. So we could have got the answer that way. For example, F, we see that 1/3 raised to the 4th is just 1/3 multiplied times itself 4 times. And of course, 1 times 1 times 1 times 1 is just 1. And 3 multiplied times itself 4 times is the same as saying 9 multiplied by itself twice. And our answer is 1/81. And of course, for example, G here, we have a -5 raised to the power of 2. When we translate that, that is the same as saying -5 being multiplied times itself twice. And of course, a negative times a negative would end up being a positive. And so, yeah, go ahead and do that. And then 5 times 5 is 25. All right, so in our next example, we see we have a -6 squared. And so according to order of operation here, we have an exponent and we have multiplication. And we need to do the multiplication first. Sorry, the exponent first. And so the reason for that is this. When we see this expression here, we actually translate it this way. So here's where the multiplication is, and there's where the exponent is. And if we write this all out, this looks like -1, and -6 squared is -6 times -6. So that's why it looks this way up here. And of course, we know from here that a -6 times a -6 is a positive 36. And that negative that's there is understood to be a -1 times the 36. And that's why we get a -36 as our answer. Okay. Now, for example I, this is different. And it's different because we do not have it written like this now. Okay. If we had it written with the parenthesis in there, then it would be very similar to the other examples that we've done. But this is not the same thing as that. So I want to make sure that we're very clear on that. So I'm going to erase this. And so when we see this situation here, we have to interpret it this way. And of course, according to order of operation, we have to do 7 squared first. And 7 squared is the same as 7 times 7, which is 49. And we get -49 for our answer here. Now, this is different from doing this. If we did it this way, then that's translating it as a -7 times a -7. So we would look at it this way. And of course, a negative times a negative is a positive, and 7 times 7 is 49. So see the difference in between what we're talking about here and what we're talking about here. So with example J, similar to that, we know that -8 squared is just -8 times -8, which is a positive 64. Okay. And now if we look down in example K, we see that when we look at this negative that's on the outside here can actually be interpreted as taking -1 and multiplying it times everything else. And so when we look at it in that way, then we see we just have a bunch of multiplication after we interpret or translate -4 quantity squared is just -4 being multiplied times itself twice. And so then from here we can say that a negative times a negative is a positive, and then positive times a negative is a negative. And so that's how we get -16 as our answer there. All right, so working on our last few examples here, we see that anytime we have some number raised to the 0 power, we know that that is going to equal to 1. And then we have plus, and we know that -3 raised to the 2nd power, or -3 squared, is just a -3 times a -3, which is a +9. And so now if we take 1 and 9 and add it together, we get 10. Similarly, for example, M, we see that -3 cubed is just -3 being multiplied times itself 3 times. 3 raised to the 1 is just 3. And minus 3, -3 raised to the 0. Anything raised to the 0 is equal to 1. So that's how we have the 1 here. And so, of course, when we multiply -3 times itself 3 times, we get -27, because we know a negative times a negative is a positive. 3 times 3 is 9. And we know that a -3 times +9 is a -27. And of course, we just carry everything else over. A -27 minus 3 is a -30. We just get more negative. And a -30 minus 1 is a -31. So that's how we get that answer there. For example, N, we see that this -5 squared has to be interpreted this way. And of course, we know that because we do not have a situation where we have parentheses like that. So since we don't have it like that, then we have to look at it differently. Okay. So now from here, of course, we have minus and then -4 multiplied times itself twice. And so 5 squared, we know that that is 25. 25 times a -1 is a -25. We do the minus, and we know that a negative times a negative here is a positive. So all of this is a +16. And then we have -25 minus 16, which is a, so -25 minus 16, which is a -41. And so in our last example, we have a -3/4 squared. So of course, since it's the negatives on the outside, we are translating that to be a -1 being multiplied by the rest of this. 3/4 squared is just the same as 3/4 being multiplied times itself twice. And so with fractions, we multiply numerator with numerator. So 3 times 3 is 9. Denominator with denominator. 4 times 4 is 16. And we have, again, our understood -1 being multiplied by all that. And of course, that gives us for the answer of -9/16. And so this concludes the video on exponential form, as well as evaluating expressions that have exponentials in them. Take care.